A rock screams through the dark at 245,000 kilometers per hour. Not from our neighborhood, from somewhere else entirely. July 1st, 2025, Rio Hurtado Valley, Chile. One telescope among 5 in the asteroid terrestrial impact last alert system picks up a white pixelated splodge 420 million miles out. Within a day, trajectory calculations confirm what no one expected. It is moving too fast to orbit the Sun. Eccentricity, 6.14. Any object above 1 does not loop back. This one will not return. Ever. Third interstellar visitor in 8 years. 3, I Atlas. The number says third. The I says interstellar. The Atlas says who found it, but nobody knows where it came from or what it really is. You have heard about the first one? October 2017. Pan-STARRS telescope in Hawaii catches 1I Oumuamua, tumbling through at 137,000 miles per hour. Strange cigar shape, no tail, no coma. Asteroid or comet, scientists cannot agree. Some whisper technology. Most say natural. Eccentricity 1.2. It exits before anyone gets a good look. Then August 2019. Crimea. Gennady Borisov spots 2I Borisov with his custom-built 65-centimeter telescope. This one shows a clear coma and tail. Definite comet. Eccentricity 3.4. Larger than the first, but still modest. Half-kilometer nucleus. It fragments near the Sun in March 2020. Both confirmed interstellar. Both gone forever. Now this third visitor arrives, and everything changes because this one is different, massive, active. Strange chemistry, and old. Possibly older than our entire solar system. Also, this script is researched and factual, using sources from nasascience.gov, published July 3rd, 2025, and the ArXiv preprint server paper 250.8.18209, published September 10th, 2025, by the James Webb Space Telescope team, along with Wikipedia's 3I Atlas article, updated October 21st, 2025. These are not generic astronomy sites. These are the primary mission pages and peer-reviewed research that astronomers worldwide use to track this object in real time. Now back to the information. Pre-discovery observations stretch back further than July. Zwicky Transient Facility in California caught it June 14th through 21st, 2025. Atlas telescopes recorded it June 5th through June 25th. Amateur astronomer Sam Dean finds it passing in front of the Galactic Center's dense star fields where the comet would be hard to discern. That is why nobody spotted it sooner. Too many stars, too much light. Then TESS. NASA's Transiting Exoplanet Survey Satellite observed 3I Atlas from May 7th to June 3rd, 2025, when it was roughly 6.4 astronomical units from the Sun. Already bright, already active. Water ice does not sublimate that far out. Something else drives this comet. Carbon dioxide ice, dry ice. It melts very easily. Turn on at 9 astronomical units, that is the CO2 frost line. All 3 show a marginal coma with potential tail-like elongation, 3 arc seconds in angular length. Comet confirmed. Minor Planet Center assigns designation 3, I/Atlas, and non-periodic comet designation C/2025N1. 122 observations from 31 different observatories by the time it gets named. David Jewett and Jane Liu using Nordic Optical Telescope. July 2nd confirmed clearly active with diffuse appearance. Miguel R. Alarcon and team at Instituto de Astrofísica de Canarias using Tidey Observatory's 2-meter twin telescope find cometary activity same date. Multiple telescopes show the coma has reddish color indicative of dust, similar to 2I Borisov. Study by Tony Santana Ross and colleagues published August 2025 reports. 3I Atlas's coma became redder throughout July, indicating evolving surface or coma composition from increasing activity. Large vertical extent suggests thick disk, old stars. 3I Atlas shows large vertical excursion when trajectory integrated back in time. Shawcruz, Kakarov, and Professor Abraham Loeb at Harvard calculate the galactic paths. Their paper, accessible on the ArXiv and submitted to Astronomy and Astrophysics, uses the MW Potential 2014 model. Local standard of rest, circular velocity, 233 kilometers per second. Orbital radius, 8.3 kiloparsecs around galactic center. The analysis reveals the 3 interstellar objects originate from distinct stellar populations. 1I Oumuamua is young, about 1 billion years old, originated near midplane of thin galactic disk of stars, age younger than 1 to 2 gigayears. 2I Borisov falls between them. Approximately 1.7 billion years old, thin disk origin. But 3I Atlas is ancient. Median age 4.6 billion years. Thick disk origin, populated by older, lower metallicity stars. Bayesian age inference indicates 3I Atlas came from old, thick disk source. 9.6 gigayears with 68% confidence interval, 7.8 to 10.3 gigayears, 3 billion years older than our solar system. Oldest comet ever observed, possibly 14 billion years old according to initial studies. Brightness at 1 micrometer wavelength implies nucleus diameter 46 kilometers for typical albedo 4%, according to Avi Loeb calculations posted on Medium August 25th, 2025. But if 99% of brightness stems from icy fragments around 3I Atlas, then nucleus diameter is 10 times smaller. Order of 5 kilometers, mass still 1,000 times bigger than 2I Borisov, whose diameter was estimated half kilometer. Hubble space. Telescope captures sharpest image July 21st, 2025, when comet was 277 million miles from Earth. Teardrop-shaped cocoon of dust coming off solid, icy nucleus. Hubble tracking the comet along hyperbolic trajectory makes stationary background stars streak in exposure. Continuing observations allow astronomers to estimate nucleus size. August 20th, 2025. Observations indicate upper limit diameter 3.5 miles or 5.6 kilometers. Could be as small as 1,444 feet or 440 meters across, most likely diameter less than 1 kilometer. Coma appears slightly elliptical, spans up to 26,400 by 24,700 kilometers, about twice diameter of Earth. Gran Telescopio Canarias, 10.4 meter telescope, captures this July 2nd, 2025. Spherex Space Observatory detects flux at 1 micrometer wavelength August 8th through 12th, 2025, suggests even larger nucleus, 46 kilometer diameter, million times larger mass than 2I Borisov. This huge gap surprises because we should have discovered numerous objects size of 2I Borisov before discovering 46 kilometer interstellar object. Amount of rocky material per unit volume in interstellar space is smaller by factor of 10,000 than value needed to deliver one giant rock this size over decade long. Atlas survey. Spherex images show 3I Atlas as point source. No dust coma or tail visible. Confusion reigns. Different instruments, different answers. Vera C. Rubin Observatory serendipitously images 3I Atlas during science validation observations. June 21st to July 3rd, 2025. Slight increase in coma diameter, constraints on nucleus diameter. Rubin would have discovered 3I Atlas before Atlas survey, if it had begun observations 2 weeks earlier. 61 kilometers per second, maximum speed at perihelion reaches 68 kilometers per second, 42 miles per second with respect to Sun. Perihelion date, October 29th, 2025, 11:47, universal time plus minus 1 minute. Distance 1.36 astronomical units. 203 million kilometers, 126 million miles between orbits of Earth and Mars. Closest approach to Earth, December 19th, 2025, 1.8 astronomical units, 270 million kilometers. 167 million miles, no threat. Passes behind Sun, late October, solar conjunction. October 21st, 2025, exactly opposite side of Sun relative to Earth. Impossible to observe with Earth-based telescopes. Avi Loeb notes in Medium article October 19th, 2025. This hideout raises questions. Under these circumstances, optimal point for spacecraft maneuver. Oberth effect makes it energy efficient for spacecraft engine to burn fuel when orbital velocity greatest. Halloween will be October 31st, 2 days after perihelion. High-rise camera on board. Mars. Reconnaissance orbiter able to image 3I Atlas with resolution 30 kilometers per pixel. Orbit correction by 10 to 15 kilometers per second during September could shrink closest approach to zero. ESA's Mars Express and ExoMars Trace Gas Orbiter observe comet with several instruments around closest approach. High-resolution stereo camera and color and stereo surface imaging system turn their eyes. Omega and SpyCam spectrometers and Nomad spectrometer attempt spectral measurements. Though comet and tail may not be bright enough for full characterization. Observations, October 1st through 7th, 2025, 30 million kilometers away. ExoMars. TGO captures series of images with Cassies. 3I Atlas is slightly fuzzy white dot moving downwards near center. Both cameras designed to photograph bright surface of Mars, just a few hundred to few thousand kilometers below. Scientists unsure what to expect from dim targets so far away. Chemistry reveals the mystery. James Webb Space Telescope directs near-infrared spectrograph toward 3, Atlas, August 6, 2025. Inbound heliocentric distance 3.32 astronomical units. Spectral images spanning 0.6 to 5.3 micrometers reveal CO2-dominated coma. Enhanced outgassing in sunward direction, presence of H2O, CO, OCS, water ice, and dust. Coma, CO2/H2O, mixing ratio 7.6 plus minus 0.3. Among highest ever observed in comet, 4.5 sigma above trend for long period and Jupiter family comets, excluding outlier C/2016 R2. Observations compatible with intrinsically CO2 rich nucleus. May indicate 3. I Atlas contains ices exposed to higher levels of radiation than solar system comets, or formed close to CO2 ice line in parent protoplanetary disk. Martin Cordner, astronomer at Catholic University of America and principal investigator, says, "When we first saw observations, it was striking. Carbon dioxide flux just incredibly high, water normally dominant thing in comets. Ratio of carbon dioxide to water 8 to 1, according to some measurements. Highest ever recorded for comet. 6 standard deviations above typical value. Ratio of carbon monoxide to water more familiar. 1.4, consistent with previous observations. Ratio of carbon-12 to carbon-13, generally similar to Earth. Indicates comet formed an environment with similar forms of carbon. Reveal cloud of carbon dioxide around 3I Atlas out to distances at least 348,000 kilometers. Mass loss rate about 70 kilograms per second. No water cloud detected. Upper limit 4.5 kilograms per second on water mass loss rate. Order of magnitude below previous claims, which reported mass loss rate, order 40 kilograms per second. Those early claims unsubstantiated. Spherex report notes lack of bright water gas coma is puzzling as 3. I Atlas was not too far outside solar system's water ice line at 2.5 astronomical units during observations. Glow around 3. I Atlas in Hubble image could originate from reflection of sunlight by fragments of CO2 ice that 3I Atlas sheds rather than dust. Teardrop shape observed July 21st, 2025, elongated ahead of object towards sun. No cometary tail opposite direction. Sun-facing glow could not have been dominated by refractory dust, with particle size comparable to wavelength of sunlight, because solar radiation pressure would have pushed dust within day to trail 3I Atlas in typical cometary tail shape. Such tail not observed beyond transverse width of glow. Scattering, dominated by icy fragments that evaporated before they had opportunity to trail. Conundrum suggests metal comes from never-before-seen chemical process. Thomas Puzia, astronomer at Pontifical Catholic University of Chile, whose team analyzed VLT observations, says we just cracked open door to a whole new world of chemistry we never had access to before. Spectroscopic observations. August 23rd show object developing classic cometary tail. Activity far from sun surprises. JWST captured object at 3.3 astronomical units. Recent VLT observations at 2.85 astronomical units. Floating through near absolute zero void for eons exposed to constant radiation of cosmic rays. 3I Atlas may have developed cooked shell on surface where CO2 ices created, says Stephanie Milam, astrochemist at NASA's Goddard Space Flight Center. Excess CO2 now heated by sun venting into coma. Nickel usually seen alongside iron when sublimated from comets. Could come from dust grains made from nickel tetracarbonyl. This molecule, highly volatile, breaks apart easily when exposed to UV light, releases nickel and carbon monoxide. May help account for high amount of activity while still far from sun. James Clerk, Maxwell Telescope. September 7th, 2025, finds hydrogen cyanide production rate 1.5 plus minus 0.5 times 10 to 25th molecules per second. 2.33 astronomical units from sun. Week later, September 14th, concentration measured again. Gemini South Telescope observations, July 5th, and NASA Infrared Telescope Facility. July 14th, detect water ice in coma. First reported July 20th, 2025. Swift Observatory ultraviolet observations, July 30th and August, first suggest presence of water vapor and hydroxide ions. Gemini South Telescope, late August, captures deep image showing comets broad coma and tail. Tail at least 35,000 miles long. Dust production rate estimated 5 kilograms per second early May 2025 at 6 astronomical units. Increases to 30 kilograms per second mid-July at 4 astronomical units. Assumes 100 micron dust grains. In line with Hubble measurement at 3.8 astronomical units. Brightening rate proportional to R to negative 3.8 H. Significantly steeper than 2 I Borisov. More consistent with dynamically old long-period comets and short-period comets in solar system. If you have been following this far, you understand this object does not fit patterns. Subscribe to stay updated as more data releases. Also, comment your thoughts on what 3I Atlas might reveal. This research is documented using real peer-reviewed sources from ARCS of 250.8.1.8209, submitted by Martin Cordiner and NASA team, September 10, 2025, describing JWST and IR-SPEC observations, plus Wikipedia's constantly updated 3I Atlas page. Tracking all observations in real time, plus NASA Science Mission page, updated continuously through October 2025. These sources represent cutting-edge astronomy, not speculation. Back to the comet. Alignment with orbital plane of planets around Sun. Coincidence of part in 500 for random orientation. Same observed for 2 I Borisov. If 3 I Atlas targeted inner solar system by technological design, this alignment makes sense. Avi Loeb and colleagues upload paper titled, Is the Interstellar Object 3? I Atlas Alien Technology to ArXiv preprint server. Paper not yet peer-reviewed. Hypothesis considers whether 3 I Atlas is technological artifact with active intelligence. 2 possibilities follow. First intention's entirely benign. Second, they are malign. Dark forest resolution to Fermi paradox would make malign more likely. Would explain singular lack of SETI success to date. Most astronomers reject technology hypothesis. Jacqueline McCleary, assistant professor of physics at Northeastern University, says, for 3 I Atlas to have started glowing as far out from Sun as it did was abnormal enough to result in theorizing early on it must be alien spacecraft. What else that's small and quick producing light? Subsequent observations revealed not only comet-like tail, but likely rich in carbon dioxide because dry ice melts very easily, confirmed as comet. Any post-discovery launch after July 1st, 2025 would require extremely high delta V GAU, at least 24 kilometers per second, beyond capability of any propulsion system available. If 3I Atlas discovered before July 1st, probe launched Earth, that date would have required delta V approximately 7 kilometers per second. More feasible to visit using probe departing from Mars, substantially less delta V required. Putative probes departing Mars between July and September 2025 need less than 5 kilometers per second for Venus intercept. Less than 5 for Mars until end July. Europa Clipper and Juno spacecraft mentioned as potential observers. NASA assets planning observations include Hubble Webb, TESS, Swift Spherix, Perseverance Mars, Rover, Mars Reconnaissance, Orbiter, Curiosity Rover, Europa Clipper, Lucy, Psyche Parker, Solar Probe Punch, and ESA NASA SOHO. Jupiter Icy Moons Explorer JUICE attempts observations. November 2025, using cameras, spectrometers, particle sensor. Coordination with Europa Clipper considered for twin ultraviolet spectrographs. JUICE currently close to Sun using main high gain antenna as heat shield. Using smaller medium gain antenna, far from Earth on opposite side of Sun. Data not expected until February 2026. Solar elongation increases moving away from Sun. December 2025 moves through constellations Virgo and Leo. Brightness dimmer than apparent magnitude 12. Passes Jupiter March 16, 2026. 0.36 astronomical units. 54 million kilometers. 33 million miles. Jupiter gravity slightly alters path. No collision. After that, no more planetary visits. Makes way out of solar system. Continue journey through interstellar space. JWST scheduled next observations. December 2025, after perihelion. Hubble performs ultraviolet spectroscopy. November 2025. Determine composition of gas emissions, sulfur to oxygen ratio. Monitor comet on way out of solar system. As 3, I Atlas comes closer to Sun, becomes more active. Volatile ices heat up, begin sublimating faster. Could potentially lead to outbursts. Comet suddenly ejects large amount of dust, brightens, even fragmentation events. Nucleus breaks into pieces like 2 I Borisov. As of August 2025, observations not detected any outbursts. Brightness and activity level appear steady. Origin from thick disk means parent star could be low metallicity star. Heavy element abundance at least 40% of suns, presumed to have formed within protoplanetary disk of gas and dust surrounding parent star when young. Rich in carbon dioxide suggests formed far from parent star beyond CO2 frost line. Temperatures cold enough for CO2 to condense into solid. At some point, after formation, 3I Atlas gravitationally flung out of parent star system, either close encounter with giant planet or star. Tracing path shows comet originated from interstellar space in direction of constellation Sagittarius, near Milky Way's galactic center, unlike previous two interstellar objects originated from southern celestial hemisphere, direction opposite to solar apex in north. Travel time from opposite side of Milky Way disk, for 1 I Oumuamua, about billion years, for 2 I Borisov, 1.7 billion years, for 3 I Atlas, 0.8 billion years. Through orbit around Milky Way, all three travel a few thousand light years closer to galactic center than Sun does. 1 I Oumuamua anomalous, much younger, extreme disk-like shape, exhibited non-gravitational acceleration, did not show cometary activity like other two. Comet will not return, ever. Eccentricity, 6.14, means trajectory relatively straight rather than curved. Highest eccentricity of three interstellar objects, greater than 1 I Oumuamua, 1.2, greater than 2 I Borisov, 3.4. After perihelion, October 29th, ventures past, Jupiter-March 2026. Exits solar system permanently. David Jewett, University of California, Los Angeles science team leader for Hubble observations, says no one knows where comet came from. Like glimpsing rifle bullet for thousandth of second, cannot project back with accuracy to figure where it started on path. This latest interstellar tourist is one of previously undetected population of objects bursting onto scene that will gradually emerge. Now possible because we have powerful sky survey capabilities we did not have before. We crossed a threshold. Astronomers estimate several interstellar objects of extrasolar origin pass inside orbit of Earth each year, 10,000 passing inside orbit of Neptune. With Vera Rubin Observatory expect to discover many more soon, perhaps 4I within few years. More unlikely but highly appealing interstellar object like 3I Atlas. When Comet Interceptor selected 2019, only knew one, I Oumuamua discovered 2017. Since then, two more discovered. Shows large diversity in appearance. Visiting one could provide breakthrough in understanding their nature, says Michael Keppers, Comet Interceptor Project scientist. While remains improbable, we'll discover interstellar object reachable for Comet Interceptor, as first demonstration of rapid response mission that waits in space for target will be Pathfinder, for possible future missions to intercept mysterious visitors. 3I Atlas demonstrates these objects not rare. Before 1 I Oumuamua. Discovery 2017. No direct evidence objects from other star systems could reach our solar system. These visitors provide unique samples of material from distant planetary systems. Insights into chemical composition and physical properties of exoplanetary material cannot obtain through remote observations alone. Serve as natural probes of interstellar medium and galactic dynamics. Reveal gravitational interactions that shape stellar populations over billions of years. Studying 3, I-Atlas provides insights into exoplanetary systems and galactic chemistry. Interstellar origin may reveal unique isotopic signatures, advancing understanding of star formation and potential panspermia theories. Interstellar objects may serve as galactic couriers, transporting dust ice and organic molecules that seed young planetary systems. If confirmed, 3I Atlas could provide first concrete evidence of chemical exchange between star systems, discovery revolutionizing models of planetary evolution. Each interstellar object offers unique research opportunities, determining where each originated, first step toward understanding diversity and dynamics of stellar populations in Milky Way. Shokruz Kakarov, graduate student at Harvard Astronomy Department. Work includes studies on interstellar objects, trajectories of spacecraft like Voyager, direct imaging, flux of extragalactic dark matter. Professor Loeb Frank B. Baird, Junior Professor of Science at Harvard. Director of Institute for Theory and Computation at Harvard-Smithsonian Center for Astrophysics. Former Chair Astronomy Department, Harvard, 2011 to 2020. Former member, President's Council of Advisors on Science and Technology. Former Chair Board on Physics and Astronomy of National Academies. Best-selling author, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. Co-author, textbook, Life in the Cosmos, both published 2021. Paperback Interstellar published August 2024. Comparisons between 3 visitors reveal patterns. 1, I Oumuamua, apparently asteroidal body, lacking detectable signs of cometary activity. Polarimetry not conducted, size approximately 100 meters. 2, I Borisov, showed clear coma. Polarimetry performed by European Southern Observatory, very large telescope. Polarization higher than typically measured for solar system comets. distinguishes 2I Borisov from dynamically evolved objects such as Jupiter family and all short and long period comets in solar system. Only object with similar polarimetric properties is Comet C/1995-01 Hale-Bopp, believed to have approached Sun only once before apparition, 1997. 2I Borisov exhibits more pristine nature, nucleus diameter approximately half kilometer. 3I Atlas clearly comet, most likely nucleus diameter less than 1 kilometer, possibly as small as 440 meters. Coma twice diameter of Earth, mass potentially million times. 2I Borisov, activity driven by carbon dioxide, not water. Chemistry unlike anything in solar system. Age potentially 3 billion years older than solar system itself. October 29th, perihelion. Closest point to Sun, 1.36 astronomical units, 126 million miles. Moving at maximum speed, 68 kilometers per second. Heat penetrates nucleus. Sublimation accelerates. Carbon dioxide vents into space. Coma expands. Dust tail grows. November arrives. Visible in sky again just before sunrise. Grows dimmer. Solar elongation increases. Moves away. December crosses through Virgo and Leo. Magnitude drops below 12. Too faint for amateur telescopes. March 2026 passes Jupiter. Final planetary encounter. Gravity gives slight nudge. Trajectory barely changes. Then nothing. Empty space. Darkness. Cold. 3I Atlas accelerates beyond escape velocity. Leaves solar system forever. Carries secrets of formation conditions in stellar system billions of years old. Chemistry forged in radiation fields we have never measured. Isotopes that match Earth, but ratios that do not. Ice exposed to cosmic rays for eons. Surface cooked by interstellar environment into shell we cannot replicate in laboratory. Ground observatories will track until signal disappears into noise. Data will flow for months, papers will publish for years, arguments will rage over nucleus size, over chemistry, over what high carbon dioxide really means, over whether thick disk origin explains composition, or whether something else happened in deep time we do not understand, over whether parent system had high radiation or low water or both, over what nickel without iron implies about dust grain chemistry, over whether comet is intrinsically CO2 rich or whether surface processes created apparent abundance. Every answer spawns 3 questions. Every measurement conflicts with another. Every model fits some data, excludes other data. This is how science works when object comes from outside all previous experience, when chemistry does not match library, when age exceeds reference frame, when trajectory cannot be traced to source. In different disk, under different conditions, survived ejection from birth system, traveled through galaxy for billions of years, crossed thousands of light years, entered solar system at angle that brought it past Mars within 30 million kilometers. Past Earth within 170 million, perihelion between Earth and Mars orbits, then exit. One pass, no return. Hyperbolic trajectory eccentricity, 6.14 guarantees it. Object arrived. Object observed. Object leaves. Window lasted 5 months from discovery to perihelion. A few more months until too faint to study, then gone. Interstellar space claims it back. Next encounter with star could be million years away, 10 million, 100 million. Might never encounter another star. Might drift through galaxy until galaxy itself changes shape. Until Milky Way collides with Andromeda 4 billion years from now. Until stellar populations we track today are scattered and reformed and scattered again. Infrared cameras and ultraviolet spectrographs, Mars orbiters and Earth satellites, professional astronomers and amateur observers, governments and universities and private organizations, all turned instruments toward one small, dirty snowball screaming through inner solar system at speeds that dwarf anything humans ever built. Watched it brighten, watched it develop tail, watched sublimation strip material from nucleus, watched coma expand to twice Earth diameter, watched carbon dioxide vent at 70 kilograms per second, watched chemistry that breaks all models, measured, photographed, analyzed, debated, published. 3. I Atlas taught us. Solar system is not isolated. Galaxy is not empty void between stars. Objects cross between systems. Carry material. Carry chemistry. Possibly carry organic molecules. Possibly carry building blocks. Question is not whether interstellar objects visit. Question is how many we miss. How many pass through outer solar system unseen. How many came before telescopes existed. How many will come after. Vera Rubin Observatory will find more. Better sky surveys will catch them earlier, farther out, give more observation time. Maybe one day, catch one inbound with years of warning. Enough time to launch probe, enough time to intercept, enough delta V, enough fuel. Get close enough to image nucleus directly, sample coma, measure composition in situ, Return data that answers questions instead of spawning more. Trajectory carries it away. Speed increases beyond our reach. Capability does not exist. Mission does not exist. Spacecraft does not exist. Can only watch it leave. Can only study light it reflects. Can only analyze spectra from distance. Can only build models from limited data. Can only wait for next visitor. Hope next one comes at better angle, better distance, better timing, better technology, better preparation. ESA Comet Interceptor launches 2029. Parks in orbit. Waits. Target unknown. Could be Oort Cloud Comet. Could be interstellar visitor. If 4I appears. If trajectory permits. If launch window exists. Maybe Comet Interceptor intercepts. Maybe humans finally touch material from another star system. Maybe chemistry becomes certainty instead of inference. Maybe isotopes get measured with precision instead of estimated from spectra. Maybe nucleus size becomes measurement instead of argument. Maybe we learn what 4.6 billion-year-old thick disk comet actually contains. 6 standard deviations above normal. Nucleus size somewhere between 440 meters and 5.6 kilometers, depending on whose measurement you trust. Mass somewhere between 1,000 times 2 I Borisov and million times depending on whose model you accept. Age somewhere between 4.6 billion years and 14 billion, depending on thick disk assumptions. Composition dominated by CO2, but with water ice, CO, OCS, nickel, cyanide hydroxide, and dust of unknown grain sizes, and unknown albedos, creating unknown scattering that produces unknown contribution to brightness that makes nucleus size unknown. Origin from constellation. Sagittarius direction, but actual parent star untraceable, because gravitational perturbations during ejection, plus billions of years of galactic orbital motion, plus close approaches to other stars, plus gravitational interactions, with spiral arms, plus molecular cloud. Passages plus everything else that happens over deep time makes backward integration useless past a certain point. David Jewett says, cannot project back with accuracy, like rifle bullet glimpsed for thousandth of second, gone before trajectory fully known. 3. I-Atlas continues inbound, coma expands, dust tail lengthens, carbon dioxide sublimates, heat penetrates deeper, activity increases, brightness peaks, telescopes watch, cameras record, spectrographs measure. October 29th, 11:47, universal time plus minus 1 minute. Closest approach to Sun, 1.36 astronomical units, 126 million miles. Temperature rises, sublimation spikes, then begins fade, starts outbound journey. November 3rd passes Venus, November observations from JUICE, December observations from Webb. March passes Jupiter, then empty space, then darkness, then cold, then nothing until next star, if ever. Hyperbolic trajectory guarantees no return to solar system. Eccentricity 6.14, path relatively straight. Exit velocity exceeds solar escape. 3. I-Atlas joins galaxy of wanderers, ejected fragments, scattered remnants, failed planets, disrupted asteroids, decoupled comets, material that never accreted, material that accreted and broke apart. Ancient rubble from ancient times around ancient stars in ancient regions we have no names for and cannot identify, because spectra do not reveal source, and trajectories integrate backwards only so far, and then guess becomes same as knowledge, and knowledge becomes hypothesis, and hypothesis becomes speculation, and speculation tells us nothing. Coma teardrop-shaped, tail points away, some dust points toward, grain sizes mixed, activity driven by CO2 beyond water ice line, starts at 9 astronomical units, increases inward, peaks at perihelion, then declines outbound, matches dynamically old long-period comets, brightening rate steep. Proportional to R to negative 3.8 H, steeper than 2 I Borisov, consistent with thick disk origin, consistent with age, consistent with radiation exposure, consistent with formation beyond CO2 frost line, consistent with low metallicity parent star. Consistent with chemistry from protoplanetary disk, different from solar system disk. Consistent with everything and nothing, because every interpretation has alternate explanation, and every explanation has contradicting data, and every data set has noise and uncertainty and assumptions about albedo and particle size and scattering function, and viewing geometry and phase angle and heliocentric distance correction and aperture size and integration time and atmospheric absorption and instrument response and calibration and background subtraction and point spread function, and all the things that turn photons into answers. Object from elsewhere, chemistry from elsewhere, time from elsewhere, age potentially predating solar system by 3 billion years, Formed when galaxy was younger, when thick disk was forming, when metallicity was lower, when stars were different. Survived formation, survived ejection. Survived journey through interstellar radiation, survived cosmic ray exposure, survived near absolute zero, survived gravity perturbations from passing stars, survived everything galaxy could throw at it over billions of years. Then entered solar system. One chance observation, one telescope. One night, July 1st, 2025, Rio Hurtado, Chile, 420 million miles out. White pixelated splodge. Numbers that did not fit, trajectory too fast, eccentricity too high, motion too straight. Follow-up confirms. Interstellar object. Third confirmed. Largest observed. Most active. Strangest chemistry. Oldest age. 3I Atlas number 3. Letter I for interstellar. Atlas for system that found it. Designation that says where it ranks but not where it came from. Not what it is, not what it means. Discovered July 1st, 2025. Pre-discovery images traced to May 7th. Eccentricity 6.14. Perihelion October 29th. 1.36 astronomical units. Nucleus diameter uncertain between 440 meters and 5.6 kilometers. Coma diameter 26,400 by 24,700 kilometers. Carbon dioxide to water ratio approximately 8:1. Brightening rate steep. Age billions of years. Origin thick galactic disk. Trajectory from Sagittarius direction. One pass through inner solar system. No return. Rest is interpretation. Rest is model. Rest is hypothesis built on measurements, built on assumptions, built on photons collected by instruments, pointed at fuzzy white dot moving across star field at speeds that make background stars streak. Rest is science doing what science does, taking data, building models, testing hypotheses, revising models, taking more data, arguing over interpretation, publishing papers, submitting rebuttals, running simulations, comparing observations, searching archives, finding pre-discovery images, extending timeline, refining orbit, narrowing uncertainty, expanding questions. Every answer splits into branches. Every branch splits into more. Tree of knowledge grows, but trunk remains same. 3I Atlas is interstellar. 3I Atlas is here. 3I Atlas is leaving. Root facts do not change. Everything else negotiable. Future surveys will discover 4I and 5I and 6I. Future telescopes will catch them earlier. Future missions might intercept. Future technology might sample. Future humans might hold fragment from another star system in gloved hands in clean room under microscope. Might measure isotopes with precision, might solve chemistry, might answer questions. 3I Atlas left behind. Until then, we have what we have. 5 months of observations, spectra and images and photometry and astrometry and everything telescopes could gather. Hubble and Webb and Sphere-X and TESS and Swift and VLT and Gemini and Atlas and Rubin and all the others. Ground-based and space-based, optical and infrared and ultraviolet and radio, every wavelength, every instrument, every archive searched, every pre-discovery image found, data rich. Answers poor, classic astronomy. Object shows up, object leaves. Object teaches us we know less than we thought. Shows us chemistry we never saw. Shows us age we barely comprehend. Shows us galaxy sends messengers and we must learn to read messages. 3I Atlas speaks language of photons. We decode into wavelengths, into spectra, into abundances, into models. Translation imperfect, meaning uncertain. Message received but not understood. Not fully, not yet, maybe not ever. Analyzed with latest techniques, published in real time. Shared data immediately. International collaboration. No borders in astronomy. Chile and Hawaii and Arizona, and Chile again. Ground and space. Mars orbit and Earth orbit and beyond. Professional and amateur. Government and private and university. All watching one dirty snowball, all measuring same object, all seeing different things, all contributing pieces to puzzle that grows more complex with each piece added. Started simple, comet from interstellar space. Became complicated, chemistry wrong. Size uncertain, age extreme, activity puzzling, origin unclear, ended profound. 3I Atlas is messenger from elsewhere carrying information about conditions. We cannot replicate, carrying chemistry. We cannot explain carrying age. We can barely measure, carrying mysteries we cannot solve before it leaves forever, carrying all answers with it back into darkness between stars where humans cannot follow, where telescopes cannot see, where questions go unanswered until next visitor arrives, until next chance, until next messenger crosses boundary between systems and gives us another 5 months to wonder what we are seeing and what it means and where it came from and what else is out there waiting in the dark. Humans measured it. Universe indifferent. Object continues. Stars pass. Time flows. Billions of years ahead, same as billions behind. Rock screaming through dark. Same as always. Same as beginning. Different only in that, for 5 months, humans knew it was there and watched and wondered and learned. We know nothing.